What is a base b logarithm? Discuss the meaning by interpreting each part of the equivalent equations b to the y equals x and log base b of x equals y for b greater than 0 and b not 1. Well, the logarithm was originally created by Napier, Scottish mathematician, and was used historically to manipulate exponents. So you'll know that when you say log base b, you're talking about the base of the exponential function. B is above, and the thing that it's equal to is the exponent of that base. And so this was used for manipulating the base, or manipulating the exponent, sorry. And then, so the value that you get out, x, is what goes into the log. So what that does is it creates an inverse, which is what we have being asked in 2. How is the logarithmic function f of x equal to log base b of x related to the exponential function g of x equals b of x? What is the result of composing them? Well, they're inverse functions of each other, so that means they're symmetrical around y equals x. And when you compose them, you get back what you started with, because that was what we discovered before, is, in fact, what happens when you compose a function that's inverse. How can the logarithmic equation log b of x equal y be solved for x using properties of exponents? Well, you can rewrite it in the form b to the y equals x. So convert log base b of x equals y to b to the y equals x. Then you use this to use exponentials. If you can convert that x into something that has a power base b, and then you can just match up the exponents. So use the theorem, if a to the u equals a to the v, then u equals v. So you got to get those bases matched up. Discuss the meaning of the common logarithm. What is its relationship to a logarithm with base b, and how does the notation differ? Well, the common log typically written without a base, but it's understood to be base 10. So really, if you said log base 10 of x, that's the same as just writing without writing anything out. That's a common log. Now, also, number 5, discuss the meaning of the natural logarithm and what is its relationship with the base b. Well, we write ln of x for natural log, and it's understood that that means log base e. And e is the number 2.718281828459045, and it goes on forever. All right, let's solve a few problems here. So the first one, number 25, I think it just kind of gives a basic idea of what you're looking at here. Now, we're going to rely on the fact that the natural log of e to the x is equal to x, because they're inverses of each other. So if I take the natural log of both sides, I get that. Now, one of the things that we can do is rewrite, actually this is before that, isn't it? Well, we know that they're inverses of each other, so that would mean that this is k and this is the natural log of h. And that's how we get the solution to what k is. Now, that's going to be a common thing that we're going to do throughout. So if I do number 30, which is log of base 2 of x equals 6, now what I could do is rewrite this as a exponential, which would be 2 to the 6th is equal to x, right? And then, of course, 2 to the 6th is just 64. And we'd have our solution like that. If I do number 37, say, which is log 10 to the log of 32, now this is a common log, which means these are inverses of each other. So in other words, I know that 10 to the log of x is just x. So in other words, this is just 32. And if I do 51, which is the ln of 1, now the one thing I know is that if I think of it this way, if I wanted to just figure out what it was, I could rewrite it as my exponential, which would be e to the y is equal to 1. Now we know that we can write 1 as to the 0 power, so that would make y is equal to 0. We can do it like that.